Good morning, everybody. A very good morning, all of you. Let's start the class. Hello, guys. This is Bhima Shankar. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country. I am expertise with the subjects of network analysis, digital circuits, and microprocessors, guys, from the last 10 years. So, we are here in the continuation of our network analysis course, complete comprehensive course. Today, we are going to solve the problems on magnetically coupled circuits, right? So, daily we are meeting from 9 to 10 a.m., guys, for these 2 weeks. So, the next, see here. If you want to plan for Unacademy Plus subscription, guys, please think of this. You can see these are the last 3 months of your preparation. So if you can afford, you can go for 3 months subscription in Unacademy, which is just 12,750 after discount. Okay. Even you take 3 months, you can watch all the old lectures and new lectures also. You can complete the leftover part without depending on when the syllabus will be completed, and you can enjoy all the benefits in these 3 months. Okay, what are the benefits with Plus subscription? You can go for live classes morning and evening. You have the crash batch, rank improvement batch, comprehensive batch, whichever batch suits for you. You can attend that. You can attend all the batches also, no restrictions. Regular exams will be there, doubt solving sessions will be there. Classes are in both the languages, all the subjects in English and Hindi also. Okay. So if you go for iconic subscription, you will be provided with personal coach, study planner, study booster services, and also personalized study analysis. That is, they will provide you one digital coach. He will help you to reach your destination. Generally, these digital coaches also, generally from IITs, I mean those who cracked GATE and doing some MTech, completed MTech in IIT, those kind of people only guide you to reach your aim once you take the iconic subscription. So if you want to plan for subscription, guys, you can understand this is 375. So these are the fee structures, but you should apply the coupon code whenever you take the subscription. Please don't forget to apply the coupon code, otherwise you don't get 10% discount. This is the coupon you should apply if you like my teaching. If you want to join an academy, when you or your friend anybody joins an academy, you can refer this code, guys. Shankar 10 is our code, which will give you 10% discount. After discount, your 1 year subscription is 27,225. 18 months is 34,000 odd, and 2 years is 39,600. Originally, it is 44,000. It will show, but apply the coupon, you get 10% discount. You can apply this coupon for any course in an academy, not for my classes. It is for total GATE and ESE subscription. Right. If you go for iconic subscription, as I show you the extra benefits, these are the fee structures for 1 year and 2 years. Okay. So if you are final year or pass out, if you go for 3 months regular subscription, it is 12,370. Okay, let's move. So this is my profile name in Unacademy. You can message me anytime for any kind of guidance, whatever. You can follow me and follow my free classes, whatever available in Unacademy also. Our Unacademy learning app is more dedicated. You can have one-to-one interaction kind of classes. If you attend few classes, you will understand the difference between YouTube classes and Unacademy classes, guys. Right. Let's start. Okay. So let's see. Thank you. I'm fine. So last lecture we discussed the basics, right? And then what we discussed is this one. Okay. Who is that? Hirak, any doubt? He has doubt in this V1 minus L1 plus M minus into minus plus M. Okay, V1 minus L1 minus M. Yeah. So, right. Transformer coupling that we have discussed. Series coupling, parallel coupling, transformer coupling that we have discussed. Now, let's continue with coefficient of coupling. Okay. Let's see coefficient of coupling. Okay, what is coefficient of coupling? The degree of coupling between the coils. The degree of coupling between the coils K is given by M upon root of L1, L2. Generally, the K varies from 0 to 1. K will be in the range of 0 to 1. When K is 1, there is no coupling. इसका मतलब क्या sir? You can say one kind of isolated coils, magnetically isolated. There is no coupling between them. K equal to 1, this is called tightly or perfectly coupled. K is maximum 1. Okay. So when K equal to 0, you can substitute in this K equal to 0, you get M equal to 0. If K equal to 1, what will you get? K equal to 1, your M will be equal to root of L1, L2. So this is the maximum value of M, guys. If you want the maximum value of M, what is that? M equal to root of L1, L2. Okay. So mutual inductance maximum value is root of L1, L2. Right. So one of the important application of the transformer is impedance matching. What is impedance matching, sir? Impedance matching mein you can see here transformer can be used to match the load impedance to the source impedance for the condition of maximum power transfer, you can say. Let us do it. Say I have a transformer. Okay. So you have the turns ratio N1 into N2. Here the notation is I1 is entering, I2 is leaving is what we follow. So here let's take this voltage as V1, this as V2. Now for this transformer, I am connecting a load impedance Z. Okay, or you can say it is ZL. What is the input impedance seen by the transformer? What is the input impedance seen by the transformer is given by the formula. We can derive it, not an issue. N1 by N2 whole square into ZL. That is, by varying N1 and N2, I can adjust my input impedance to the required value. That is what we call impedance matching by using transformer. We will see it in the problems also. Because in an ideal transformer, the ratio of V1 by V2 is always equal to N1 by N2. It is always equal to I2 by I1. You can also say V1 I1 equal to V2 I2. Here I2 is the leaving current from secondary. If examiner gives you entering, you can take negative. I2 is leaving current from secondary. Okay. Listen. Let me prove this if you want. If you take this current as I2, okay. What is the input impedance, sir? Input impedance of this network is given by input voltage by input current. Okay, sir. But current I1 can be written as what? Current I1 can be written as, or V1 can be written as what? V1 is equal to N1 by N2 into, you can say, V1 can be written as N1 by N2 V2. That is 1 by I1. In place of V1, you can write N1 by N2 into V2. But what is V2, sir? What is V2? I2 into ZL. So 1 by N1, N1 by N2, sorry, 1 by I1, N1 by N2 into V2. What is V2, sir? I2 into ZL. So I2 by I1 is equal to again N1 by N2. So N1 by N2 into N1 by N2 into ZL. So it will give out to be N1 by N2 whole square into ZL. This is the input impedance seen by the transformer. Good morning. Okay. Okay. So let's move to the problems now. Let me check your doubts. 1 minute, Hirak. In transformer coupled circuit, when it is opposing, okay, it is L1 minus M only, it has satisfied KVL. What is your doubt in this? Check it if you want. L1 minus M and M. Minus L1 minus M dA1 by dt minus M into d by dt of I1 plus I2. So minus L1 plus M into dI1 by dt minus M dI1 by dt minus M dI2 by dt. We are getting something wrong. Acha, just a minute, guys. I have given wrong. V1 minus L1 minus M. Okay. Minus L1 plus M. Okay. Minus M dI by dt. We have done. Just a minute, guys. It is giving plus, right? So what shall we do? Just a minute. In that case, here also, in aiding also, minus L1 dA1 by dt. Here plus is there. This side it is minus. Okay, okay. I'm sorry for that. Thank you. Who is that? Thank you, Hirak. Let's correct it. Don't worry. Here it is opposing only. Instead of opposing, let's take it as aiding. Okay. So in this case, it will give you. Now it is fine. 1 minute. I will change it total part. Okay. And here, sorry for that. So please see here. This is the circuit V1 L1 di1 by dt plus M di2 by dt, L2 di2 by dt, M. It is aiding connection first time discussing. When we discuss first one is aiding connection. In this case, you get plus. Okay. Energy stored equal to half L1 I1 square plus half L2 I2 square plus M times I1 by I2. This is aiding connection I am discussing. Okay. So L1 minus M, M, L2 minus M. V1 minus L1 minus M into di1 by dt minus M into di1 by dt equal to 0. So V1 minus L1 plus M di1 by dt minus M di1 by dt minus M di2 by dt. So plus M minus M cancels. V1 you say take other side, both will be plus. Okay. So this is perfectly true for aiding. So whatever I have given last time, just ignore this. Okay, guys. So similarly, for opposing, I'm sorry for that. I try to save the time by copy paste, but it happened. So in this case, it will be, we need not prove it again as we discussed previously, L1 plus M, L2 plus M and M. Okay guys, minus M. What is V1 sir? L1 di1 by dt minus M di2 by dt. What is V2 sir? L2 di2 by dt minus M di1 by dt. Thank you. So clear. Good morning everybody again. So okay, let's go to the problems. So let's start the problems. Before starting this problem, let me give you small problem first. As we discussed the impedance matching, let me give you the question on impedance matching. Right. So this is the question given. Determine value of N for maximum power transfer in 5 ohm resistor. You people try it and tell me the answer. Just use the previous concept, you can do it. By using the previous concept, you can happily do it. Please guys, try the question, tell me the answer. N equal to, very good, N equal to 3. Chalo, very simple question. See here. What is the input resistance seen by the transformer here is N1 by N2 whole square into 5. So you can replace this circuit by using this figure. This is V sir and this is 45 and the remaining part can be replaced by N square into 5. N square into 5. So for maximum power transfer, what is the condition required sir? N square into 5 must be equal to 45. N square must be 9. N must be equal to 3. Okay, N must be equal to 3. So is it clear? This is how you can use your maximum power transfer condition for impedance matching guys. So that is, you can say transformer can be used to impedance matching. I told. What is the meaning of impedance matching sir? There your load is not matched to the source, but by varying the value of N we are able to match the load to the source. Okay, so let's move to the next question. So next question is getting loaded. Where is that? Yes. So this is the question given in GATE 2014. I'm just loading that question. I mean opening that question. So let me give you that. I want you people to answer this question. Please try to answer, guys. I hope it is visible. Okay. Two identical coupled inductors are connected in series. The measured inductance for two possible series connections are 380 microhenries and 240 microhenries. Their mutual inductance in microhenries is. Try this question and tell me the answer, guys. I want your active participation, guys. Please try it. Yes, do it. What is the right answer? Try it. Three 0 1. I don't think so. 35. I don't think 35 also. Mutual inductance 35. 70 and yeah, maybe 35 is right. Yes, very good. So let's do it, guys. Here one important point, two informations are given. Generally, inductance connected in series and the measured for two possible series connection. What are the two possible series connections? हमारे पास क्या क्या है? Aiding or opposing. If you take aiding, L equivalent is equal to L1 plus L2 plus 2M. That you should take it as 380 because in aiding you get maximum value, na? So, but here examiner give one more information. It is important. Identical coils. Otherwise, you get three unknowns and two equations you cannot solve. Identical का मतलब क्या? L1 equal to L2. So L plus 2M is equal to 380 henries, microhenries. Then what is L plus M, sir? Take 2 common. It is 190 microhenry. One equation is obtained. Second equation is L1 plus L2 minus 2M because they are opposing, because decreased compared to 380. So we should assume it as a opposing. So you get 240 microhenries. Then L minus 2M equal to 240 microhenry. Then L minus M equal to 240 microhenry. From that you can solve 1 and 2. What will you get? And this is 190, sorry, 120 na? Chalo, 120. So you get 2L equal to 310 and L will be equal to 155 and M will be equal to 35. Okay, the mutual inductance is 35 microhenry. This model appeared in GATE 3 times. Okay, let me show you one more question. One more question of the same model. Just a minute. So try this question. This question you answer it. It is given in 2015 GATE paper, guys. You can try same model. Two identical coils each having inductance L are placed again identical. Okay, together on the same core. The overall inductance is alpha L. It is obtained by interconnecting these two coils in this two coils. The minimum value of alpha is. Tell me your answer. Phenyl 2. Minimum alpha is 2. Any other? Any other answer? Point 5. 2. Let's do it. You don't say aiding now. We should take both the cases. Okay. What is that? Let's find the minimum requirement is L1 plus L2. If you take minus 2m is your L equivalent. He said identical. So L plus minus 2 times. Okay. You take maximum m is equal to root of L1 L2. You should take that because to make the inductance minimum. To make the inductance minimum by subtracting we should take the maximum possibility, that is L into L. So L plus minus 2L, this is equal to 0. So L equivalent is possible to be 0 also. That is you should take alpha L. What is the alpha value? It can be 0. Okay, when these two coils are connected in, it is the assumption series opposing. Series opposing, it will give minimum possibility. Okay, if you get maximum here, so you can take plus. Is it okay? So why you took m equal to root of L1 L2? That is the maximum possibility. When this is maximum, you get the equation size minimum, equivalent size minimum. Okay. Okay, right. Satish, I have answered your doubt. Okay, it is in subtraction. If this negative term is more, overall value will be less. Chalo. Before, I don't want to do this question. Let me do one more question. So this is also one of the most frequently occurred question, guys. See here. This is the question given so many times in your exams, that is determine ABCD parameters of the network shown. जो नेटवर्क गिवन है ना, इसका ABCD पैरामीटर्स, ट्रांसफार्मर का ABCD पैरामीटर्स है. It is a very famous question given at least so many times in your GATE exam, other IES exam and other competitive exams, guys. So let's do it. So many AE exams, JE, so many times it appeared. So you know, for the transformer, what is the relation, sir? Transformer का relation क्या, sir? V1 upon V2 equal to, what is that? N1 upon N2 equal to I2 upon I2. But I told that I2 should be leaving. Here my I2 is entering. So minus I2. Okay. If examiner give leaving, you should take leaving on. But for ABCD parameters, what are the equations? V1 I1 equal to A V2 minus B I2. To put C V2 minus D I2. Where this I2 I1 are the entering currents. That is the notation we followed. Let's take the same. So what is V1, sir, here? N times V2. What is I1, sir? Just from this equation. You take this other side. What is I1? What is I1 is minus 1 by N I2. Okay. Fine, sir. Add 0 here. Add 0 here. 0 into anything is 0. 0 into anything is 0. So now you guys, you see here the ABCD parameters is equal to n 0 0 1 by n. Okay, n 0. Rahul, that is input impedance. Why you are finding input impedance here? We have already done that in network analysis, two-port network topic. Okay, listen here. Please see, this is the T parameters of the network. Transmission parameters, ABCD parameters of a transformer is N0 1 by N. See, examiner can give 1 is to N also. Then answer changes. Don't remember this. Remember the process. Now we can prove what is AD minus BC, sir. What is AD minus BC? Batao. AD minus BC is N into 1 by N. N into 1 by N is 1 minus 0. 1 minus 0 is how much, sir? 1. That is AD minus BC equal to 1. Transformer is a reciprocal network. Transformer is a reciprocal network. Don't forget two-port networks after coming to this topic, guys. Okay. So what is the inverse T? 1 by N 0 0 N. If you require, you can find it. So please listen here, one more thing I want to say. Examiner can give you in any way, you should be able to do N1 into N2, 1 by N. Anything he gives, you should be able to do it. Okay. Is it clear? Minus is there in the representation itself. That's why this minus will not come in the answer. Okay, Chinna? This representation you should remember in the two-port networks we discussed. Chalo. If you want to see here, V1 by V2 equal to N1 by N2 equal to I2 by I1. Here I2 is entering. Here please listen here, my dear friends. See here. What are the H parameters is asked? Let's try that also. If the examiner asks, we should be able to do V1 equal to H11 I1 plus H12 I2. Sorry, V2. I2 equal to H21 I1 plus H22 V2. Okay, fine, sir. Then just manipulate these equations in your required format. What is V1, sir? 0 times I1 plus, what is that? N times V2. Similarly, what is I2, sir? Just take this other side. Minus N into I1 plus 0 times V2. So from these two equations, we can get the H parameters 0, N, minus N, 0. H12 equal to minus H21. Again, we can say reciprocal condition. Then this is the inverse of this matrix. You can find Hg and T dash with this information given by examiner, but you cannot find the Z and Y parameters. You cannot find the Z and Y parameters. Okay, so let's see. Okay, this problem is waiting for us from long time. Let's complete it. Let's complete this before going to the next question. Okay, so here this is the inductance, this is the inductance J8 minus J12 and 10. We need to find the condition for value of K for series resonance. You people try it and tell me the answer. Try it and tell me the answer. Give a try and tell me the answer. Write the answer, guys. What is the value of K for series resonance? Determine the value of K for series resonance. See, again, I want to say one thing. Most of the people messaging me, they are asking, sir, notes, notes. Okay, they are not saying their introduction anything. Sir, admin group. I am always saying, please listen. Every single lecture we discussed is in our Telegram channel. Even you join the Telegram channel late, go to the files section. All old notes is also available. When you message me, please message in a proper format. Your name, okay, you are watching which particular lectures, YouTube or which one in YouTube, which particular lectures, YouTube network lectures. I want to join the group. Once you join the group in the Telegram channel, you will be getting the notes. Go to files. Total notes is available. Okay, let's do it, guys. Okay, it is a series resonance. So for series resonance, XL must be equal to XC. This is the condition required. So what is XC, sir? Minus JXC. XC is how much? 12. What is XL equivalent? Please listen here. What is L equivalent? 14 kahan se? I have power maximum value of K is 1 only. How you people are getting more than 1? L1 plus L2 plus 2m or minus 2m. You see current is entering through dot in the first case, leaving through dot in the second case. Compulsory you should take minus only because they are in opposing. Then what is the answer, sir? L1 plus L2 minus 2 times m equal to k into root of L1 L2. Okay, so our job is to find k. Okay, sir. Very good, sir. Please find the K, sir. Chalo, bhai. Multiply with omega both sides. Omega L equivalent equal to omega L1, omega L2 minus 2 times K into root of omega L1 into omega L2. Because omega in the here square in the root omega square. So that's why omega omega. So omega L equivalent will be how much required? That is the XL equivalent must be equal to 12. This must be equal to 8 is the first j, omega L1 8, omega L2 kitna 8 minus 2k into root of 8 into 8. So here what will you get? 16k is equal to 4, k equal to 1 by 0.25, k equal to 0.25, correct. Is it okay? चलो नेक्स्ट क्वेश्चन लेता हूं आपके लिए. आगे चलेगा नेक्स्ट क्वेश्चन. सो अभी व्हाइट बैकग्राउंड ट्राई करेगा क्योंकि वी आर ट्राइंग ओनली ब्लैक बैकग्राउंड फ्रॉम लॉन्ग टाइम. लेट्स ट्राई बैक व्हाइट आल्सो. This question is given in one of the UPSC paper. This is the question. Read it. Try. Determine current in 8 ohm load. Determine the current in the 8 ohm resistor. You try it, guys. Please calculate and try the answer. Just I will give you 1 minute. After that, I will do it. .25 no. 2 ampere wrong. Sushil once check it. Yes, 1 ampere is the right answer. You people please read the question properly. 8 ohm resistor, not input current. So here what is the input resistance seen by the transformer is 1 by 2 whole square into 8. That is 8 by 4. 8 by 4 is 2. So what is the meaning of this, sir? You can see here 10 angle 0 degrees, 3, and the remaining part we replace with 2 ohms. Then the current is I1. So what is I1 is equal to 10 by 3 plus 2, which will give you 2 angle 0 degrees. So if you take this current as I1 and this current as the load current I2, we know the ratio I2 by I1 is equal to N1 by N2. I2 by I1 must be equal to N1 by N2. Okay, so what is I2, sir? It is I1 by 2. I1 is how much? 2 angle 0 degrees by 2 is 1 angle 0 degrees. That's all. Okay. So let's move to one more question. I want 100% answer in this question. It is a previous GATE question given in GATE 2015 instrumentation paper. It is given in the instrumentation paper of the GATE 2015. Find V naught. बताओ आंसर क्या? What is the value of V naught? How do you calculate V2? You can do like this if you want. Who is that? Satish. By voltage division principle, you get 2 angle 0 degrees here. So you can give 2 angle 0 degrees here. By voltage turns ratio, you can take 4 angle 0 degrees. 4 by 8 is the answer. Right. What is the answer? No. Remaining students, give your answer. What is the right answer? 0.5 कहाँ से आया? What is V naught? What is V naught value, guys? Same as input? No. Yes. Vi sin minus V sin omega t by n. Right answer, Krishna. Right answer. So actual question is this one. I forgot to give you properly. Okay. Please listen here. We have discussed this point yesterday class. If current is source is given the energy, current is entering through dot in one coil. Mutual induced EMF is positive at the dot of second coil. Or both the dots should have same polarity is our notation. Listen. So this is your V2. This is your V1. We know V1 by V2 must be equal to N1 by N2. Then what is V2, sir? N into V1. Then what is V0, sir? Minus V2. Because V0 examiner required V0 is in reverse polarity. Minus V2 का मतलब क्या? Minus N into V1. V1 is what? Vi sin omega t. That's all. Okay. I changed this 1 by n. Otherwise, remaining people who have given the answer 1 by n Vi sin omega t negative, correct. Okay. Very good. So please understand here, polarity is important. Current is entering through the dot here. At the other dot, okay, you get positive for the mutual induced EMF. और दोनों डॉट का पोलैरिटी सेम लेना चाहिए, सिंपल रूल. देन दिस इज म्यूचुअल इंड्यूस्ड ईएमएफ. एग्जामिनर वांट वी नॉट इन रिवर्स ऑर्डर, सो यू शुड फाइंड अकॉर्डिंग. चलो, लेट्स मूव to the next question. So try this question, guys. It is again repetition of the question which we have done earlier. So two identical coils are connected in series. Their equivalent inductance is 30 Henry. If the connection is reversed 9 Henry, what is the value of M? We have done this same model. It is also appeared in your previous exam. I told you 3 times it appeared. So you people try this question and tell me the answer. Try the question and tell me the answer. Right. So tell me the answer, guys. So two identical. Okay, two identical coils are connected in series. Their equivalent inductance is 13 Henry. If the connection is reversed, it is 9 Henry. What is the value of M? So what is the value of M, guys? Array M equal to 1. KKR, how you got 7 here? Maximum value of M equal to root of L1, L2. Is it 9 root 13 is 7? So let's try. So the first case, L1 plus L2 plus 2M is equal to 13 Henry. Second case, L1 plus L2 minus 2M equal to 9 Henry. Then you subtract this minus this, you get 4M is equal to 4 Henry. Yes, M equal to 1 Henry. M is equal to 1 Henry, L equal to 5.5. Okay, M will be equal to 1 Henry. Chalo. Next, let's move. Right, let's do this question. Let's try this question. Determine the equivalent inductance between A and B. Between A comma B. आप लोग try करके बताओ आंसर. So by the next week you will be getting the feeling of completion of the subject. You can add to your library. So whenever you solve any other subject, analog electronics, power systems, everywhere, whenever you apply network analysis, you will remember my subject and me, definitely. Right. चलो guys, try करो, try करके आंसर बताओ. What is the right answer here? Determine the equivalent inductance between AB. $17 Henry is very good right answer. Right answer. देखो, listen. Very good guys. Here current is entering through dot. Here also current is entering through dot, but here current is leaving through dot. So first two are in aiding, second one is opposing. So how to do it, sir? I will show you different ways to solve it. L equivalent will be equal to, write the individual inductances first. 8 Henry, 9 Henry और 10 Henry. Okay sir, then क्या करना sir? Listen. What is the mutual inductance between these two coils, sir? Mutual inductance between these two coils is 2 Henry. That is between 1 and 2 you have 2 Henry. They are in additive, so take plus 2. 1 minute. Between 1 and 3, what is the inductance, sir? 4 Henry. Aiding or opposing? Opposing. So minus 4 Henry. Plus 9. Again, see here, come to 2. 2 and 1 entering here. So additive plus 2. 2 and 3 entering here, leaving here. So opposing minus 3 plus 10. Between 3 and 1 opposing na, entering here and leaving here. So minus 4. Between 3 and 2 entering here and leaving here. So minus 3. So calculate करो आपको 17 हेनरी मिलेगा. Okay, so this is one method. Nahi hai to sir, you can do by different way also. This is 8 Henry, 9 Henry or 10 Henry, right? So here current is entering and leaving here. This is the 2 Henry given, this is the 3 Henry, and this one is 4 Henry. So what is the L equivalent between AB? Direct formula I am giving you. Okay. L equivalent is equal to L1 plus L2 plus or minus 2 times M12 plus or minus 2 times M23 plus or minus 2 times M31. What is that? L1 plus L2 plus L3. So first individually 8 plus 9 plus 10. Now you tell me between 1 and 2 what is the inductance? 2 Henry. So is it additive or oppositive, sir? Additive. So 2 times 2. 2 and 3 what is the inductance? 3 opposing. So minus 2 times 3. 3 and 1 what is the inductance, sir? It is entering and leaving opposing minus 2 times 8. Okay. So minus 2 times 4. In that way also you can do the solution, you will get the same thing. So okay, this is another method, or you can try by Laplace also. Find ultimate aim is to find the voltage and current ratio at the input impedance. I will give you some homework questions for you. This is a homework for you. You need to find the equivalent inductance between X and V when the following are shorted. That is when A and B are shorted. Now little complex questions are coming that we discuss tomorrow class. Okay, B and C and A and C. You can understand our process, right? One is we started with the theory, then I gave you the foundation. Today we did little, not much difficult, little basic kind of questions which are from the previous papers. Tomorrow we will do little complex kind of questions. Okay. So can anybody in the class tell me what is the wrong in this figure? Is there any mistake in the figure? Is there any mistake in the figure, guys? Batao bhai, is there any mistake in the figure? Yes, Rahul, please don't prepare for your exam. You can see the previous year papers and you can justify that. First, prepare for the subject only. I suggest, Rahul. First, learn the subject. If you prepare criticality, easy thing you can do easily. Okay, prepare for the toughest part. Dots to correct hai. Satish, another observation. Another observation. Please carefully observe and tell me one thing where the question is wrong. अरे टर्म्स तो छोड़ दो भाई. Anything else? You need to find 4 answers. Okay. Are bhai, here X and Y, no problem. That is okay. Listen, you should identify this thing. Sir, L1 equal to 2 Henry, L2 equal to 2 Henry. Mutual should be less than or equal to root of L1, L2. It cannot be 3 Henry, sir. Question to wrong hai. Please take it 1. Is it clear? Question is root of 2 into 2. Okay, it should not be for 3 Henry is given, which is impossible. Mutual inductance cannot be greater than root of L1, L2. So what is the right answer? Sorry, what is the correction I am doing is I am giving it as 1 Henry and you can try the question. Okay, चलो एक और क्वेश्चन भी दे रहा हूँ. These two things you try it at home and check it. I think you get 49 by 5 Henries. You check it at home. Tomorrow we will do it in the class. Tomorrow we will do it in the class. Okay, please understand here. Don't worry much by seeing the rectangle shape. Shape can be anything. That what is the meaning of this, sir? Between these two, you have 2 Henry. Between these two, you have 3 Henry. Okay. So let's see how to find the L equivalent in this kind of questions also. These things we will discuss in the tomorrow class, guys. Okay. Chalo. So tomorrow I will finish the magnetic coupled circuits and next I will start what we call three-phase circuits most probably. So guys, so If you want the notes, again I am saying go to the Telegram channel, join this Telegram channel, go to the files, you get all my notes. Same with this Telegram channel also. Okay, so any one of them you can follow and you will get the notes. Right. In our Notion page also you will get the notes. So daily we are meeting 9 to 10 guys. Follow our channels and share with more number of students so that every single student will get the benefit from it. Thank you very much. Thank you all. Love you all. Bye bye. Chalo, we'll meet tomorrow again, same time. Have a very great day and nice day. Thank